Okay, last example, I want to do an exercise from the book. It's number 8 in this chapter. So this question says, in experimental bioengineering trials, a successful outcome was achieved 73 times out of 120 attempts using the standard procedure. Okay, so they're doing some bioengineering thing, and there's the old way, and then there's an experimental new way they want to test. So using the old way, the standard procedure, they tried it 120 times, got a success 73 times out there. And with a new procedure that they're testing out, procedure, a successful outcome was achieved 101 times out of 120. So they did 120 of each. The old way, they got 73 successes. The new way, they got 101 successes. So they did the same number of tries, but got more successes with the new procedure. That seems like it would suggest that the new procedure is better, but maybe it was luck. 120 is not a huge sample. It could easily be luck. But they did a lot better, right? Like they got almost 30 more successes, 30 out of 120, that's like a quarter. Like they improved by like 20, 25%. So not a huge sample, but they got a big improvement. And if you get a big improvement, that can overcome the fact that it's not a big sample to show that there is a difference. So the question asks, what is the evidence that the new procedure is better than the standard procedure? Okay, so that's how the question is worded. And it's annoyingly vague, actually, when they say, what is the evidence? So I think that basically what they're saying is find the p-value. Okay, so the p-value is sort of the measurement of like the strength of the evidence. The p-value is small, there's strong evidence. The smaller it is, the stronger the evidence is. Okay, so this is like their code, I believe, for find the p-value. And what should we use for alternative hypothesis? Our null hypothesis is that they're going to be the same. That they're the same. Our null hypothesis is that p1 equals p2. That the new procedure is no better. It's the exact same. Our alternative hypothesis, well, we have two options again, right? We could use the standard alternative hypothesis of not equals, or we could specifically focus in on the new procedure being better. Okay. I'm assuming that a success is a good thing and better means more successes. So the new procedure being better would mean a higher success rate. And if I number these in the order they're giving in the problem, then the first one is the old procedure, the second one is the new procedure. So new procedure better would mean the old one is smaller than the new one. Okay. I'm going to run the hypothesis test both ways, get both p-values. Let's flip over to MAT375. Stat, basic statistics, two proportions. The old way, it was 73 out of 120. The new way, it was 101 out of 120. Let's do it first with a not equals, see what we get for our hypothesis test. So very small. Let's get lots of decimal places here. So with not equals, using the normal approximation version, this is 0.000027 is my p-value. p-value equals 0.000027. That is extremely small. That is strong evidence that the new procedure is at least different from the old procedure. So our alternative hypothesis was different, and it came out higher. So if it's different, we're really finding it's different because it's on the high end. But let's redo this with the alternative hypothesis that is specifically focusing on, is the old one lower than the new one? Okay, so I chose less than here because group 1 is the old procedure, group 2 is the new procedure. If group 2 is better, then group 1 is smaller than group 2. That's what came out of our sample, but we want to know, is that difference statistically significant? So scroll down to our p-value. Again, it's 0 to 3 decimal places, so very strong evidence. And now it's 0.0000137. 0.0000137. Now that, something I haven't mentioned before, that's actually half of what we got for the not equals. Basically the only difference between the one-sided, like with less than or maybe with greater than, and the not equals one, is that the not equals one has both tails, and the less than only has one of the tails. So the not equals one is pretty much always just double what you would get if you just had the less than. Okay, so either way, this p-value is very, very small, much smaller than our normal testing values of 1 and 5%. So we do have strong evidence that the new procedure is giving us a different answer. All right, so those are my 3 examples for comparing 2 proportions. Later this week, we are supposed to have a test. That was my plan, right? So maybe I'll do some kind of review day with the next class. And then I'll post the exam sometime next week. I think I said I would post it Thursday next week to be done through the weekend. I might end up posting it earlier than that if I feel like putting the test together before doing new material. I mean, this 10.2 stuff isn't actually going to be on the test, but before doing yet another new section, I might just post the exam and get it up there so people can get started like early, and then worry about the next section after this, after I've put the exam together. I'll think about it. We'll do a review next class, and then I'll post the exam sometime next week, or some. I'm making this on Friday, so we'll do a review early next week for the Wednesday class, and then probably post the exam in the middle of next week sometime before starting to post videos on newer sections. Okay, so that's enough for today. I'll see you tomorrow.